Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our problems in our study guide for Chapter 3, test number 1. A big part of this test is going to be graphing and deriving rules from incomplete tables and using the rule from the data that's available in the table to complete the table. So I'm not going to go through all of these. I'll do a couple of them, and then I'm going to show you what the answers are on the next page. And then if you have any questions about this process, you can ask me before you get started on your test. Generally, what I look for is see if you can just do it in one step. So in a case like this, 10 becomes 14, 5 becomes 9, and -7 becomes -3. In each one of those instances, we are increasing the value of x by 4. So the rule has to be that the value for y, the output, has to be whatever x is, 10 plus 4, 5 plus 4. -7 plus 4, and with that we can complete the rest of it. So this must be 24, since 20 plus 4 is 24. And this number, you're going to go in reverse now. So what number do you add 4 to get -4 for an answer? That would have to be -8, since -8 plus 4 is -4, and 3 plus 4 is 7. Okay? Here's another situation where one step will get you to the answer. What do you do every single time to go from x to y? It looks like every one of these, you are taking x and you're subtracting away 3. So y has to be equal to x minus 3, which makes this number be 8. Something minus 3 took you to -8, so I believe that would have to be -5, since -5 minus 3 is the same as -5 plus a -3 to give you -8. And then 12 minus 3 would be 9. Going to a little bit more complicated examples. I guess problem number 3, we'll do this one. This tells me right here that there's going to be a -5 happening, because wherever x is equal to 0, whatever that number is, has to be the number that's being subtracted or added on at the end. For instance, in this particular one, if we said x was equal to 0, it would have to be -3. And this one, if we said x was equal to 0, it would have to be +4, right? So where x is equal to 0, the output, that particular input of 0, is a very important number. That's what's being either added or subtracted at the end. So now let's think about this. What would you have to do to 10 to get it to 25, but actually you have to get it to 30, right? Because you are subtracting 5 away from that. So I believe that's going to end up being a 3. So if we take and multiply x times 3, then take away 5, what do we get? So 10 times 3 is 30, minus 5 is 25. 6 times 3 is 18, minus 5 is 13. And so that has to be the rule. So that means that 15 becomes 45, so that becomes a 40. And -7 becomes -21, so it becomes -26. And then this one, what would that be? This is one where I might have to show some work. So our output is -8, and our rule is 3x minus 5. So I would add 5 to each side. So that becomes -3. So what are you going to multiply times 3 to give you -3 for an answer? That would have to be -1. Okay, so let's go ahead and take a look at all of these tables. Sure enough, x plus 4, x minus 3, 3x minus 5. Go ahead and take a look at these other answers. Look to see if you can see the connection between the input value and the output value in all of these given quantities. So you see how you're taking and multiplying this times 3 and then changing it to its opposite. So you're multiplying everything times -3. Here, you take half the number, then add 2. Half the number, then add 2. Half the number, then add 2. And so that ends up being your rule. So I'm going to scroll down. If you want to check all of these, pause and go through and check all of your work, and then unpause when you're ready to see the next few problems. taking a look at problem number 9, you could have either said y is equal to x divided by 3 or 1/3 times x. Either one of those means the exact same thing. Here you triple your number, then add 2, triple your number and add 2, triple your number and add 2, triple your number and add 2. That ends up being the rule. And for problem number 12, this one was probably the more complicated one because it involves you actually squaring the number. So -2 squared is 4, and 4 plus 1 is 5. -1 squared is 1, plus 1 is 2, and so on and so forth. For problems 13, 14, 15, and 16, you were asked to take these input values and plug those numbers into these given rules and find the respective output values. And then once you've got those output values, then you can graph those. And so I'm going to have the graph on the next page. So you might have chosen to graph yours with different scaling on your x and your y axis. So what you need to do is not look at the direction that the line is going or how steep it is, but look at the points on the lines. Check the y-intercepts of each one. Then maybe check where x is equal to 2 on each one of them. Maybe check where x is equal to -2 on each one of them. So check those points. If you got all of those points in the right order, then chances are your graph is right. I'm going to turn the page now just so you can see the graphs. If you want to look at this a little bit more, go ahead and pause. Otherwise, let's move over to the next page. And this is what the graphs would look like. Okay, so here are all of the tables written in a horizontal kind of an array. So taking a look at 13 and 14, you can see there is the 0 or the negative. No, there's the -2, 0. There's the 0, 2. No, is that 0, 1? That is. That's 1. That's 2. So 0, 1. Here you've got the y-intercept of 0, -2. Here you've got 2, 4. There's the 2, 4. There's the 0, -2. Here your y-intercept is at 0, 2. That's right there. And there's your 2, 0. That's right there. And maybe your -2, 4 is right there. And then the last one was actually a parabola. So your y-intercept is where 0 is equal, or if x is 0, y is equal to -6. And let's see, if x was equal to 2, y was equal to -2. And if x was equal to -2, y was equal to -2. So notice this symmetry that's happening here. It's like there is a line of symmetry right down the middle, and each one of these outputs is exactly the same on either side of that line of symmetry. Okay? Alrighty, so that is the study guide for Chapter 3, Test 1. Hopefully you're understanding these concepts well, and we'll do a bang-up job on the chapter test that's coming. All right, take care. Bye.
Hey, feeling good, like I should.